So guys, in this video I'm going to discuss the put marbles in bags problem which occurred in today's LEETCODE 330 challenge. If you have any doubt regarding this, you can ping me up on Instagram. Even you can join my Discord server. I provide both the links in the comment section. I will pin them. So it is stated that you're given us an array, okay, and you have to divide it into k parts, and the score of that array will be like if you divide it into k parts. So let's say if I divide it into two parts, so it can be 1 3 5 1 or 1 3 5 1 or 1 3 5 1, right? These are the possible things. So the score will be the first and the last element of this we will add, and the first and last element of this we will add, and we will add the whole thing. Okay, so what will the score? 1 plus 1 plus 3 plus 1, that is 4, right? So 4 plus 2 is 6. For this it will be 1 plus 3 plus 5 plus 1, that is 5 6 7 8 9 10, that is 10, right? For this it will be 1 plus 5 and plus 1 plus 1, okay, plus 1 plus 1, that is 5 6 7 8 8, and we have to find out the difference between the maximum and minimum score. So that is 10 minus 6 is 4, right? So this is what basically the logic says. Now if you notice one thing, no matter whichever pair you are considering, no matter however you partition the arrays, there are two elements that we will be adding in the result, okay, in this thing. That is the first element and the last element, right? See, in this we are adding 1 and 1 no matter what. In this also we are adding 1 and the last one. In this also we are adding the first one and the last one. So no matter whatever it is, we are going to add them. So while considering the difference between them, we can exclude these, right? We can exclude these. So how many ways are there to partition an array? Okay, so let's say the array is of size n. Okay, this is what the array looks like, 1 3 5 1, right? So you can put a partition, like if you have to divide it into two parts, so you have got only one partition. Okay, so you can put a partition over here, or you can put a partition over here, or you can put a partition over here, right? So if I put a partition over here, apart from 1 and 1, what are we going to add? We are going to add 1 and 3, right? Apart from 1 and 1, we are going to add 1 and 3. And if I put a partition over here, so apart from 1 and 1, what we are going to add? 3 and 5. So 3 and 5. And if I put it over here, apart from 1 and 1, what? 5 and 1, that is 1 and 5. Okay, so you get it, like how many are possible? Okay, how many are possible? If I put a partition over here, so if I put a partition over here, I can put the element which comes just before the partition and just after it. If I put a partition over here, just before that, just after it, right? Just before this or just after it. So this is the basic logic behind the code, what I am going to explain. So let's say this was, okay, this was not array, I think this was weights, right? Okay, so this was weight. So we can make another array called ARR of size n minus 1 and run a loop from I is equals to 0 to I less than n, I plus plus. Don't run it from to n, run it till n minus 1, because size of ARR is n minus 1. Because see, if there are 1 2 3 4 elements, the number of partitions are 3, right? That is n minus 1. So that's the reason why I've made it n minus 1. So this is basically the, okay, let's rename it. Let's say this is partition array. Okay, so what partition of I becomes? It becomes weight of I plus weight of I plus 1. This is a very simple logic. Like I have seen such a problem in GFG, I think. Sorry. So so now we have all the values of the partition. That is, for this partition is 3 plus 1, that is 4. For this 5 plus 3, 8. For this 5 plus 1, 6. Okay, so yeah, the partition array looks like this. After doing this, then we are going to sort the partition array. Okay, so what will becomes, it becomes 4 6 8 after sorting, right? And then we have to run a loop from I is equals to 0 to I less than k minus 1 I plus plus. K minus 1 is this k thing, okay? Because as I mentioned that if I am going to divide it into two parts, the number of partition will be k minus 1, right? So this is the partitions. We are just entertaining the partitions portion, okay? not the number of part it is being divided into. So this, so answer was equal to 0. Okay, remember this. So answer plus is equal to partition. Okay, one will start from the end and one will start from the beginning. So this will be n minus 2, that is n minus 1 minus 1, and minus I. Okay, that is, this is starting from the end, minus partition of I, that is starting from 0 to k minus 1, and this is going from uh, n minus 2 to n minus 2 minus k plus 1, that is n, oh, whatever. Okay, so you get it, right? You get it. So, and then we are going to return answer. Now let's do a dry run on this 1351. Okay, so 1351, the partition array will be 1 plus 3 4, 5 plus 3 8, and 1 plus 5 plus 1 6. Then we are going to sort the partition array so it becomes 4 6 8, and then we are going to run a loop from 0 to k minus 1, that is from 0 to 1, but excluding it, right? 0 to less than 1, right? So we are going to consider only the 0. Okay, 0. So partition of n minus 2, that is n was 4, 4 minus 2 is 2, 2 minus 0, that is 2. Okay, so 0, sorry, yeah, 0 1 2. So this 8 minus partition of I, that is 0, that is where this is from the end and this is from the beginning. That's what I meant. Okay, so if I subtract them, so 8 minus 4 is 4, right? And check the answer, it is 4. This is a little bit complex, but a good one. I'll tell this code was a good one. So that's it. I think you can check the code. Okay, pardon my handwriting, it's kind of not good. So that's it. Thank you.